And thanks for coming to the Dash community call. This is for the 10th of May. And so I'll go ahead and cover what we talked about last week. And so last week we did more of a discussion on ACL tags. And we also, it's easier for me to go off of these notes. We talked about the SmartNIC Summit again. It looks like OCP is coming up. We talked about ACL tags again here. And then we talked about how nice it would be to have an example of maybe how the matching works here. And I put that in the notes here about, I sent it out, maybe someone would volunteer to take a look at that for us. We also talked about when were changes going to be in the SONiC repo with respect to SYNCD, and Sasha Alexander gave us an update on that. And then we talked about PR 346, where we were waiting on changes here to SCI. And so today, I think we were going to continue the discussion of ACL tag. I had a request on that. And then if you guys have anything else you would like to talk about, just let me know. But anything from the meeting minutes from last week? Okay, then I guess we should get started. Anyone, Excite Labs, did you want to volunteer to have a convo about the ACL tags?
Yeah. So this is John.
Yeah, hey, John. Should I stop presenting, John, or should I keep the screen up?
I'm going to present some slides. I'll put my camera on.
Okay.
Slides. And I'll apologize in advance that my slides are not that good, but
Nice.
hopefully we'll get the point across. Okay. Can people see this?
I can.
Okay.
Yeah.
So like at first, I just want to talk about like what was the current ACL rule API before we added tags. So the rule API before we added tags had sorry, this is still has the tags in there. See, I told you my slides weren't that good.
That's
okay, so before we had the tag, basically the matching of a rule is based on a list of protocols, a list of source prefixes, a list of dest prefixes, a list of source port ranges, and a list of dest port ranges. And the logic for matching a rule was a rule matches if the packet has a protocol that's part of the list of protocols, and the source address matches one of the prefixes in the list of source addresses. The dest address matches a prefix in the list of dest addresses, and the source port matches one of the ranges or one or more of the ranges, and the dest port matches one or more of the ranges. And so there's an and kind of logic where each field of the 5-tuple has to have a match within the lists of acceptable values for those fields or prefixes for those fields. So I think this was understandable. I think everyone, understands this match logic for the ACL rule before tags were introduced. And if there's any question on this, we can talk about that. Otherwise, I'll go to the next slide. Okay.
Got it.
So this ACL tag feature was added as a requirement to Dash. So it's good to think about like, well, what is the purpose of the ACL tag feature? And these are the purposes I came up with. There may be others, but one is it provides an abstraction to the tenant for grouping common sets of prefixes. So rather than, reusing the same prefixes over and over again, or lists of prefixes over and over again in your rules, you can just refer to a set of prefixes with a tag. It's sort of an indirection that adds a level of abstraction. And it also provides the potential of both communication and memory efficiency for the control plane. The control plane doesn't necessarily have to store the rules in a form where all of the prefixes are fully elaborated. The control plane could store the rules in a form where the rules refer to tags instead of prefixes. And so in the requirements for this feature, this prefix tag table is defined. And the object is a tag, and the attributes is a list of prefixes. It's possible that several tags could contain the same prefixes, overlapping prefixes. There's no requirement that these tags have lists of prefixes that are orthogonal from each other. It's just a tag is refers to a list of prefixes. In the way I think about this is that tags are used as macros in ACL rules. When one or more source tag or dest tags are present in the rule, then the matching logic is equivalent to the tags being logically expanded into the list of source or dest prefixes for that rule. And so maybe there's confusion about what's the correct behavior of matching on a rule with tags. I think it's pretty simple if you just think of the tags as a macro that's expanded into the prefix lists for that rule. Doesn't mean you have to implement it that way, but the matching should be equivalent to a rule that is implemented that way. So if hopefully this was understandable, and if not, we can just
There's
pause.
a question in the chat. Gerald's like, can we not have a list of ports?
Can we not have a list of ports? Not sure I understand the question.
Gerald?
Well, you basically have a list of prefixes. Why not list of ports? I mean, if they're going to be reused over and over.
Oh, you mean a tag for like a list of port ranges?
Yeah.
I mean, I suppose you could, Gerald, but I think that I think that the tag on the prefixes is like maybe more logical in the sense that as a tenant in the cloud, I may have hundreds of VMs, and maybe a set of those VMs serve some function, a different set of VMs serve a different function, and so like a tag with like hundreds of prefixes seems reasonable, and so it's like a nice sort of shorthand or indirection for potentially very large lists. I think certainly you could apply the same kind of feature to lists of ports, but I think that like those maybe don't tend to be as large as like the lists of prefixes. But I mean it would be reasonable to have a tag feature for ports and protocols and everything, but I think it's the prefixes that are the ones that are like where there's like large
scale.
Yeah, largest number of prefixes, and it provides like a nice shorthand for that.
And this is what we've been talking about for at least 4 weeks, right, John?
Right.
Exactly.
Right. So this is the feature as it's been defined and as I interpret, the feature. I didn't define this feature. So if we take a look at like what's the rule API with tags, well, a couple more attributes have been added to the rule. A list of tags, source tags, and a list of dest tags. Okay, well now what's the match logic? Well, the match logic for this is, that the protocol of the packet must match one or more of the protocols in the list of protocols. But when it comes to the source address, it's a little bit more complicated. The source address must match one or more of the prefixes in the source prefix list, or it must be associated with one of the prefixes for one of the tags in the tag list. So there's an or kind of logic there. And again, it's not just one tag. that prefix could be associated with one or more tags in the tag list. And then the same is true for the dest address in the, matching like one or more of the prefixes in the dest prefix list, or one or more of the tags in the associated with one or more of the tags in the tag list. And then the port, source port needs to match, a range, one or more ranges, and the dest port has to match one or more ranges. So there's kind of an or kind of logic that's created by adding tags to this API. But again, the tags, have a set of prefixes associated with them, and it's as if those prefixes have been expanded into the source prefix list or dest prefix list. Logically, that's what the feature does. Okay, is there any question on this?
Could you repeat that last sentence one more time for me?
Yes.
The tags have a set of prefixes associated with them, and then the source and dest. What was that?
Yeah. So let's say you had a tag. I'm going to call them email servers. I'm going to make that up. And the tag is a list of email servers. If you included that tag in this rule, it's equivalent to have adding that actual list of prefixes itself to the rule. Like adding the tag to the rule is equivalent to adding those prefixes to the rule. Like they could have been added in the list of prefixes. They didn't have to be represented as a tag. Like logically, it's equivalent. It's like a macro. I mean, I keep calling it a macro.
Right.
But that's what the tag is. It's just sort of a logical expansion of those prefixes into the rule.
Okay, thanks.
Okay.
Anyone else have a question?
I have a question. Yeah, I have a question. Mircea here. I understand, based on what you are saying, why is this not a function of the user interface? And when it's passed down to hardware, it's not already expanded and provided as a list like before. Why do we need to provide these tags all the way to the hardware and not just expand it unless the hardware optimized based on the implementation, how they want to compact them and do other things?
Yeah,
I'm not getting why we need to pass the tags to the hardware.
Right. It's a great question, and it's a question that I'll bring up in these next slides. And I agree. Like, is this really meant to be a data plane feature? Why is it being exposed to the data plane? Why wasn't this just a feature, sort of a user feature and a control plane feature? But I think it was proposed as an API. And so because it was proposed as an API, this is what is being attempted to be implemented in the data plane. But I think if you just defer that question for a little while, I think we should have a full discussion on that. Okay. So great. Let's talk about what's implemented in the P4. So what's implemented in the P4 is a prefix search that associates a prefix with a bit vector, where each bit in the bit vector represents a tag, and it's limited to 32 tags. Now, the requirement for the feature was that the feature would support a scale up to 4K tags. But this implementation in P4, basically, you can do a lookup on a prefix, and it gives you a vector to tell you which tags the prefix is associated with. Note that that's actually kind of backward from the API that was proposed in the feature, where a tag is the object, and the object contains a list of prefixes. This kind of reverses it and says, hey, given a prefix, tell me which tags are associated with it. Okay. Now, they're just, they're equivalent to each other, but the P4 kind of implements it sort of in the opposite way of the, I would say the intent of the API. And so then the ACL table implementation does not actually perform the intended rule match logic. So this vector of tag bits does a ternary compare. And the ternary compare has this property that it doesn't really implement the OR. Like if the address in the packet matched on multiple tags, the ternary compare won't match. That basically this bit vector sort of is constraining in that it can only really match on one tag at a time and not one or more tags. And likewise, if there was a match on a tag, as well as a match on just a prefix that's in the rule itself, that also can't be done with a single rule in the way that this is implemented in P4. So the solution that's been talked about in some of the previous meetings, I apologize I wasn't on the last meeting, is that, well, we'll just insert multiple rules. So, if you can't represent the logic of matching, in the way that was intended by the API, let's just insert multiple rules to sort of cover that. And I think that this is very problematic. And the reason is that there's a combinatorial explosion of rules that may need to be inserted. So the example I give is, suppose you had 20 source tags and 20 dest tags, and as well as like a list of source prefixes and a list of dest prefixes. This explodes to 1,600 rules. And so what the tenant considered to be like one rule has now exploded into the data plane to be 1,600 rules. And there's, the current requirement of the data plane is that, that there's 1,000 ACL rules. And so, I don't.
I didn't understand. When we expand, it is just expanding the list of source or destination prefix list, right? Why would it expand to 1,600 rules? It will be expanded to 2 more rules.
No,
right?
No, because think about like let's say a prefix. You do a search on the prefix and you get a bit vector, and let's say that bit vector has 20
If you're
bits.
expanding the tags, there's no bit vector, right?
There is, because this is what's implemented in the P4, right? So let's say you had a prefix and you look up the source address. And let's say this bit vector that's 32 bits wide has 20 bits set. Okay. There's no way to program a single rule with the 20 bits set that you can match on. Because if you programmed a rule with all 20 bits set, now what you're requiring is for the source address to match all 20 source tags, not just a single source tag or multiple source tags, but all 20. So the solution here would be to insert 20 rules, let's say, one with each bit set, right?
Okay.
But let's say that that's also a cross product with the dest tags. So, I can match on one of 20 source tags. I can match on one of 20 dest tags. I would need 400 rules to express like all the different combinations of which source tag and which dest tag matches. And then combine that with a list of source prefixes and a list of dest prefixes, and those each could double the number of rules, and you get to this combinatorial explosion, okay, of in this example, 1,600 rules. And I don't think that this is unreasonable. I mean, I don't think that this is an unreasonable rule. And so this is like very problematic for multiple reasons. One, it doesn't address this artificial constraint of 32 tags per ENI. The requirement was 4K. And then the explosion of rules in the data plane could have significant impact on the performance of the ACL. I mean, it really depends on the vendor's implementation, but scaling the number of rules could directly impact performance. And the only reason why the number of rules here are being scaled is because the P4 implementation of an ACL doesn't really implement the match logic that's required of the feature. And so this also, you know, let's just say in the future, there are more like per rule kinds of features added, like for example, debug counters. Well, if you needed a debug counter per rule, now you need 1600 debug counters for this one rule that was exploded into 1600 rules. So this is like in my mind, the most important point about the problem with the P4 implementation of this feature is that it's imposing this requirement that rules be expanded into multiple rules because of the cross product of tags and, you know, the source and des prefix lists. And, you know, in the past it was like, oh, it'll just be 2 rules, but it's not just 2 rules. It's, you know, it's a cross product. It's a full cross product.
I mean, one view, John, is that cross producting of bit vectors is just an artifact of the reference model, not of any dash implementation.
Yes, that's right.
I don't know if that's what's intended by the reference model is, oh yeah, you have to do this for the reference model, but implementations can avoid that if they have a clever way.
Yeah, and that's what gets to my next slide, Andy, is like, you know, can we sort of relax, you know, hey, the reference model can't deal with, you know, multiple tags, you know, matching on multiple tags in the same rule, or it can't deal with a list of prefixes and tags being matched in the same rule. The actual dash implementation must deal with that. But the reference model doesn't, and so it's like, you know, it's you know, some test cases, you know, might not pass on the reference model that must pass on, you know, a vendor implementation. That would be one way to deal with this. I don't know that it deals with the constraint of 32 tags, but you know, the point I'm trying to make here is that it really should be dash that defines the desired data plane feature abstraction and API, right? And that the P4 implementation constraints should not force dash APIs or dash constraints or potential performance impacts. And then there are several options here of like, what can we do about it? Like in the case of ACL tags, but I think that this is like even a higher level discussion. There may be other features in the future that, you know, have this same kind of issue where, you know, a very nice abstract feature can be defined with a nice API and you know, and a behavior could be expressed perhaps in English, but that behavior is very difficult to express, let's say, in the current form of P4. And so are we going to let P4 then ultimately define what our APIs are for Dash? And I think it's a mistake to do that. I think that there are ways that we can deal with this. You know, again, we can eliminate the requirement that P4 pass the full set of tests. This particular feature, as Mircea, I think, pointed out, like, why is this feature even a data plane feature? Like, if the ORC agent was capable of expanding a rule into multiple rules, why didn't an ORC agent just expand the tags into a bigger list of prefixes?
I think I'm not sure if you get a chance to look at the requirements PR that was raised recently regarding tags. But from a Dash perspective, I've listed out what is the requirement, what are the different behaviors if based on the bitmap, bit vector size. And it's also possible that if the SI implementation doesn't need to deal with tags, or agent can expand based on what is the capability returned, right? So it's kind of a flexibility that we want to add.
Okay.
I'm not sure if you got a chance to read through those.
I did not read through that, but I mean, if what you're saying is like, if a data plane says it doesn't support the tag capability, then the ORC agent would just, you know, would just expand the tags into like a larger list of prefixes.
That's right.
Yeah, I mean, I think that would be good. I mean, I think that would enable you know, a data plane to decide whether it wants more rules or whether it wants bigger lists of prefixes.
Mm-hmm.
That, I didn't have that as an option here, but I think that that's a pretty good option. But I also think that the current API for associating prefixes with tags is kind of like turned on its head. Like the idea of a bit vector for associating a prefix with a set of tags is not really natural. The natural API here is that a tag is associated with a list of prefixes. And the only reason why this is encoded as a bit vector is for the purpose of trying to get a P4 behavior to implement this in P4.
The other thing maybe orchestration agent needs to consider is that the tag, the way it's been defined from user point of view, can be any tag value, right? It doesn't necessarily have to be within a bit vector fashion.
Right.
Whereas, what's highlighted here is that the data plane needs to work on bit vector. So if it's a free-form tag from user point of view, there is some translation that needs to be done to be fit in bit vector. And if so, orchestration agent can help with that.
Right, but again, the bit vector representation is really like a synthetic thing that's being created only for the purpose of a P4 behavioral model implementation. Like, I think that that it's not the natural way to represent the relationship of prefixes and tags. The natural way is that a tag is the object and is associated with the list of prefixes, not the opposite. Now, the opposite,
the P4 behavioral model defines the pipeline model for the hardware, right? So if that is not reflecting the behavior, then we have a problem there, right? Like each vendor can implement it in different ways. If we,
I think that, again, the natural representation is that a tag is an object and has a list of prefixes. The only reason why it was turned into a bit vector, in my opinion, is to try to create a P4 behavioral model.
Yeah, because the P4 behavioral model defines the pipeline model, but also like it's again like a slightly, if you think in a different way, right? The packet is coming with an IP address, right? Now this IP address is the one that has to match different tags. Like, how do we make that comparison if there is no prefix to tag mapping provided? Like it's the vendor to implement.
Look, if this were a C model, and I'm just going to give this as an example. If this were a C model, I could write a very, very simple algorithm, right? That would take the address in the packet. It would take the rule. It would iterate over the list of tags for the rule. It would then iterate over the list of prefixes for each tag in the rule. And it would like linearly search the list of tags and then the list of prefixes within the tag until it determined whether there was a match for that address on that rule. So like there's a, like, again, if it were a different language, it would be like a very simple algorithm that could express the desired match.
No, hold on. So the rule, when you say it will C model, it will go through all the tags. There's no tag in the rule, right? In the actual hardware, right?
No, but this is a behavioral model. This isn't hardware. Okay. This is a behavioral model, right? It's not hardware. So the behavior is, if you iterated over all of the tags for a rule, does the prefix, and then for each of those tags, you iterated over each of the prefixes, you could determine whether the address in the packet matched a tag for that rule, right? And that's the behavior, and that's the correct behavior. And it's a very simple algorithm. Now, how a vendor implements that algorithm in their data plane is up to them, right? But what we're doing here is we're saying, oh, somehow we're thinking of the P4 model as the hardware, and like this is how the hardware has to work, and it's not. The P4 model is a behavioral model. It's, I don't want to denigrate P4, but it's like it doesn't easily match it doesn't easily allow you to implement this kind of logic that in some other language would be just like a simple, loop. So like, I don't think that we should let that constraint of P4 like drive our APIs and drive how vendors implement their own data plane. It's like imposing constraints that aren't really there. And it's also potentially imposing performance and scale and other issues that weren't necessarily there. It's really a result of trying to implement this behavior in P4.
Yeah,
And may I just suggest that I'm not hearing anybody who writes in P4 respond to John's concerns. And there are people I can see on here who have implementations of P4 and let alone know P4. So is anybody in the P4 camp here have an opinion on this, or knows a way around this, or knows how to change this? I mean, I'm not really hearing anybody in the P4 arena say anything. So can somebody give some kind of counter to this? Because it's like, I think we understand John's view. I don't understand the P4 view because nobody's speaking up.
Yeah, I have an opinion. This is Chris.
Okay.
Thanks. And John and I talked, full disclosure, last week. We had a little bit of a meeting of minds on this. I just want to reiterate my view of what the priorities of this working group are, and it kind of resonates with John. We probably shared our brains a little bit, so this may look familiar, but I think the two non-negotiable deliverables of this working group are a data plane behavioral spec that we can all agree with, and it can be in English and diagrams or something. Doesn't have to be executable. And a really good SI interface so that this can be integrated. To me, those are table stakes for the output of this group. To me, and everything else is a nice to have, in my humble opinion. A behavioral model.
I would argue no.
Okay.
Number 3, if you just took the P4 out, I don't care if it's P4. See, we talked about this many times, but we settled on P4 for lots of good reasons, I guess. If you took the P4 out, the behavioral model, it was always part of the high priority. This is supposed to have
so you
a
want to put that
behavioral
in the
model.
must.
It's supposed to have just an API without a behavioral model is like, wow, that's not
like a day without sunshine, to paraphrase Anita Bryant, right?
So
That's
the P4
people.
kind of, if you want to separate that up, but a behavioral model is required.
Okay.
Long term, and for innovation to happen in the future, for new entrants and everything, the behavioral model is important, and it's important for us to test.
Okay.
Because it should be the golden image, and we always agreed on that. So I don't know why we would make that.
So Joe, would you say that the behavioral model has to express like 100% of the API feature set?
It should.
Okay.
The behavioral model. Forget the P4. You guys can argue over that, but the behavioral model should have 100% of the set.
Okay. So, thank you for weighing in on that, Gerald. So, nice to haves, API generation from the P4 model, right? We could always have written the API by hand, but we have a nice tool to auto-generate it. But that shouldn't be. That's the tail, not the dog, in my opinion. So, compilable. I don't even want to get too much caught up on these. What I wanted to say was, I agree that we need to have a proper API, and it shouldn't be dictated by the way we write it in P4. Okay, if the P4 seemingly convenient way we wrote the P4 for this generates the wrong API, then we have to backtrack. And what we may need to do is write P4 code that produces the same packet in, packet out behavior that we want, regardless of how awkward the P4 ends up being, to accommodate today's language. We may need 6 tables and some weird actions to combine and or different outcomes. It doesn't matter. It won't produce the right API automatically, but we can handwrite one or two APIs. And then behind the scenes, translate it to the P4 interpretation. P4 wasn't designed to do the kind of things we're asking it to do in this particular instance. That doesn't mean it can't evolve. I mean, we also didn't have 2 years ago add-on MIS. Right? It was a response to industrial needs. So it's possible that over time, some of these features will make their way into the language and the backends, but we shouldn't let that stop us, so to speak. We might have to do something awkward under the hood. And the automatic code generation to me is not the most important part of this discussion. We can skip this auto generation for this API. And also, I feel like this whole tag mechanism is kind of a control plane convenience. It's not really describing the data plane behavior. Like John said, it's more of a macro. We're really matching on IP addresses. Right? We're not matching on tags in the data plane. The tags are just a way to represent the contents of the lookup tables in a concise way. And I don't seems like the only argument for it is efficient
I think
efficient
that's
list efficient configuration format.
I agree with that, and that's the reason why we want to provide to SAI this tag in a different
Mhm.
way, which each vendor can leverage. But
Yeah.
I think it's interpreted in a different way right now.
So
think,
so it's
yeah.
yeah. So it seems like it's an optimization, and maybe it's a optional capability, or if it's not optional, then the the vendor implementation can expand it into individual entries in the cross product. But we need some, checks and balances on the combinatorial explosion. It has to probably reject configurations that won't fit. I would recommend we back up and come up with the best SI interface for this
No,
feature.
I think we have this introduction of capability, right, where the vendor can say like bitmap size is 0 and our agent will expand. But the whole point here is the end of the day, given a tag and the bit vector, it can drastically reduce the repetition of the prefixes and the data structure usage, at least according to our understanding. But we expand and give, that's fine, but it should not cause like memory high memory utilizations or any hit on performance. That's the whole idea about like using this tag
Mhm.
and coming up with this model. So we can expand, we can go with what vendor is returning, but our end goal must match what we are
Yeah,
trying to
maybe.
achieve. Yeah.
I have a few observations as well. Um, th- First of all, definitely agree that we need the behavioral model and we need the um, uh, rep representation of the data plane that we can all refer to, and we can generate tests from the test standpoint, from the functional standpoint that we have been working on from the test harness standpoint. It will be good to have the behavioral model for sure. The other part here is like, um, uh, the behavioral model is implemented in V1 model and all of that, and it takes time to implement that. And I have brought this up earlier too. I feel that the APIs, Dash APIs, need to be accurately defined first. And again, from test harness standpoint and the functional tests that we are writing, without the SAI APIs, we are not able to implement those tests at all. We need to utilize the APIs for, in this case, in ACL case, in metering case, in HA case, we don't have those APIs at this moment. I just feel that if we can accurately define the Dash APIs, separate that from auto derivation, auto generation of APIs from the behavioral model, keep those two separate, it might help, and that way we will be able to tell the community and anyone else to look at SAI APIs as the standard.
I think Reshma, I think this we have analyzed in the past also. Like sometimes the auto generated ones and the manual ones were not same, and then we have
Mhm.
to, modify the manual one to again to this auto-generated one. So I think then at that time we kind of probably agreed to have this auto-generated method to generate SI API so that it's in sync between the
It needs to
dash.
be in sync for sure,
Mhm.
is it possible to say which one comes first, right? We don't want to block the community from vendor implementations and test case implementations without having the accurate APIs defined. That
See,
is
I,
one
I
thing,
think again
Yeah.
going back to what Gerald said, right? The
Mhm.
behavioral model is the must have. So and that can change the SI generated APIs based on how we model the behavioral model, right? But if we come up with a manual generation of SI API, it's highly likely that it will go for a change after the behavioral model is defined, and then
Yeah.
it's an extra effort for the vendor to again now go and change according to the new auto generator. At that time, the arguments would be like, okay, we cannot make that change because the behavioral model has generated a new set of APIs, right?
Yeah.
So
I,
So
I think
real
I think
implement.
you're letting the behavioral model push you around on what your APIs are. I mean, I think it's like that's backward, right? You should define the API to the abstraction that you want the data plane to implement. And then
Yes.
the data plane should be forced to implement that abstraction, even if it's ugly in the data plane.
And even if that
Agreed.
means like you could have a completely generated API, you could have a partially automatically generated API and just manually do the tag part, which would be a small fraction, I would think.
yeah, I think
Agreed.
that's of course doable, but I'm saying
Agreed.
like in general, the
So
model is
mhm.
We
Yeah,
can
go
put an annotation in the P4 code saying don't auto-gen and handwrite that, just like we've already handwritten some other APIs, right? And then we'll make the P4 code bend to our will. And it may be awkward, but there's probably a way to do this by having multiple lookup tables, have the control plane code distribute the tag, expand the tags under the hood as an optimization, and the P4 code will produce the right result. It just won't be auto-generating the API because there's no one table, right? Or there could be a fake table somehow that just acts as a placeholder for an API, but it's not actually executed. If we want to auto-generate it, there may be a way to do that too, right? It's like a facade table.
Alexander or Marian, have you heard of anything like that since you do so much P4?
I mean, manually generated control plane APIs are the norm, I think.
Yeah, but based on what? I still don't understand. We don't have a.
Based on what the northbound API callers want.
But who said that there is a northbound API caller? It's not always true.
That there's a northbound caller to the SI APIs, or else nothing, no dash shackles ever get
So-
configured.
Yeah, so basically, what is needed for the transformation or whatever we're trying to program to what is required in the complete format for a vendor to go ahead and implement that in the hardware, right? That we are defining in the control plane.
Yeah, but let's say there is a new feature. There is no northbound for it. It's completely new. What are we basing the APIs on?
On the abstraction that you want that API to have. Not on the implementation of the API, but on what abstraction are you trying to provide with that API? What feature
On the
abstraction
feature
are you trying
level.
to provide
Yeah,
with the API?
I'm looking at the feature. How do I know? How do I know what this API came from? I'm just trying to say that API alone won't be enough to explain what the feature is supposed to do.
Text and block diagrams.
Of course, there's also an English description, there's also a requirement description, but ultimately that results in here's a feature we want, here's an API that represents the abstraction of that feature, and that's what the data plane should implement.
And the data plane P4 code, someone who's adept could read it and say, yes, this is going to execute that API. It's just the headers weren't auto-generated. So what? That's a nice to have, right? We never, the headers don't have to be auto-generated to be correct.
The CCL tag, actually, what we're talking about here might be a good case to add the infrastructure to be able to do just that, to basically define to have whatever we need for the capability override, so that the arc-agent in this case would expand before pushing to psi, or defining a psi API that it's not generated by the P4. I don't think we have all those pieces. It might be the good time to have those pieces.
So one example that I could think of where we have seen such, I mean, I think we have had prior examples of this where P4 code dictates how the SI API should look. One example I could think of is this ENI attributes. So I would have assumed that SI API for ENI should have all the attributes with the create call, but what we have today is the MAC address comes, the ENI MAC address is one of the key attributes of the ENI, but it comes as a separate API. And then we associate that to the ENI. So things like this are like examples of how the SI API has been changed to kind of accommodate the P4 behavioral model that we have.
I just I'm just thinking about it in this way. We implement it in the P4 behavioral model and derive the SI APIs and then hand modify it on top, whatever is missing in the sign, right? Is it possible to do the reverse, to that we define the dash APIs and then once we implement it in the behavioral model, if there are any changes needed, we can always update those dash APIs?
I mean, Reshma, I think this is all going back to our original discussions. I would let, I mean, Marian or someone who's generating the SI APIs more. Do you have any feedback, or I can?
I think what's not talked about is the effort that goes into API integration, all of the SONiC work, SI releases, backward compatibility, rewriting work agent code whenever it changes.
I think we have faced that in the past when we hand generated the APIs and then had to coordinate the efforts of changing the API again.
Yeah, but that's irrespective of what's under the SI layer, P4 or not. You know, if you change the SI layer from auto-generated code, you have that same problem. So I think that's a wash. Yes, implementing the translation from the ideal SI layer into our behavioral model may be a lot of grunt work, right? But we have the right interface. Having the wrong interface will haunt us forever.
I mean, the SI API, like you mentioned, it's got ripple effect all the way to the north, right? I mean, that's a fact. You already have that right now. So I suppose, so far, I guess maybe it's been easy, quote unquote. I'm not saying it's easy, but to have the P4 generate what was needed and made sense. But you still have the work of, okay, does the API generated work, A, for the feature, and B, for everything else above that, the orchestrator and whatever, to actually configure it, right? You always have that step, no matter what. So
yes,
and as far as I'm concerned, as far as ACL tag is concerned, this is just what we have now. It just doesn't make sense to me. But I mean, we've been talking about this for 4 sessions.
5 weeks.
So. Yeah, so I think that's pretty clear.
Mhm.
But
yeah,
I would say though, I mean,
ACL tag is not driven really by the feature. ACL tag was going from actually from how the control plane can provide additional hints to SI implementation. If we want to exclude that particular thing from behavioral model, probably that's a discussion that we can have. But other features that actually do packet transformations and all that to first define APIs, then try to fit behavioral model to it, and see that we missed something only after APIs are accepted in SAI, but we didn't have behavioral model back then, and run into those issues later. That's a bigger problem for me.
And from a vendor standpoint, we have the same problem. I mean, when I implement SAI API, I don't want to have to revisit that 6 months down the road. So I agree with you there. I mean, once the API has to be set in stone, done.
Right. I think even for the ACL, when we introduced tag, there was always this confusion if it is an AND operation or an OR operation, right? So if we right away generate handwritten SAI APIs and the vendor implements it, it may be different behavior across different vendors, unless it is all clearly called out. So I think that's where the behavioral model can potentially help, right? Because
based on what we talked today in the previous slides that John had about what the feature was about.
yeah, I think that's
the logic is specified there, right?
Seems like one short paragraph makes it real clear.
It's the OR business between the prefix and the tag.
Yeah, but this is where the behavioral model can define with the I mean, like,
if we agree this is the interface, I don't think anyone is having trouble understanding this slide here. It doesn't even have to be written in P4 to do this, right? P4 could just have the same, scalar list of prefixes, the cross product, and the control plane in our behavior model can just expand it under the hood.
Yes.
We don't have to even make it in P4. It's not a data plane. It's actually not even a data plane feature. It's more of a control plane convenience. This is syntactic sugar. And I think, like John said, we went backwards trying to make P4 auto-generate the API because we had a history of doing that, but it's not the most important part of this, project. It's a convenience.
And it can still auto-generate the control plane API for everything except tags, potentially.
Yeah, and the tags can just be syntactic sugar at the SAI to data plane translation layer. I mean, we don't the tags aren't really looked up really in the data plane. They're just a way of describing the entries. Now, if P4 language had semantics, or if we had an architecture, and that's something, Andy, I wanted to get your opinion on. Do you think this would actually require different P4 language constructs or just a different architecture to allow different match type?
I mean, if we defined an architecture with a different kind of match type or this kind of capability natively in the data plane, I think it would be a reference model only kind of architecture or feature. It wouldn't ever be implemented in any hardware platform, in my opinion. Mm-hmm. We could do that. I mean, that's kind of what Marian and others did when they created this port list and list match kinds. I don't expect to ever see that in any hardware platform, but I think they added it just for the purpose of writing this reference model.
You don't think BMV2 could implement it if someone took the time?
Easily, with the kind of for loop, iterate through all the prefixes kind of thing. Yeah. But nobody has volunteered to do that, including the ones proposing the match kind.
Yeah.
Anybody can. It's open source. That doesn't mean everywhere is walking distance if you have the time. It's giveaway work.
And that's a volunteer opportunity in the P4 group, Andy, to take to the P4 group?
Sure. I mean, it's been a volunteer opportunity for the past year. I mentioned this a year ago, and I said, is that ever going to be done? And it sounded like nobody. I mean, it can still be taken up anybody. I'm not saying it's not hard to do. It's time consuming. It'll probably take, it'd probably take somebody a couple months if they wanted to do it. but no hardware target would ever use it. It would only be probably used for dash and no other purpose.
Mhm. Okay, well,
So, one thing maybe people can weigh in on here is that, I thought I heard Marianne say like, hey, the tags are being made available to the data plane as a hint. Like the data plane might be able to take advantage of those tags and do something more efficiently with those tags. Or, you could say, oh, I don't support tags, and the ORC agent will just, expand the tags into larger prefix lists. Like, does anyone in this community think that taking these tags as hints helps their data plane? I don't see it. I don't see it how it does. I think that, not having the tags in this API does not in any way diminish Dash. Of course, the control plane and everything else above could use tags all they want, but I don't see that it diminishes the data plane to remove the tag feature altogether.
So
I think it
Prince,
diminishes the
we
control plane
have
API
experience-
efficiency significantly if we remove the tags from the control plane API.
No, we are not talking about southbound, right? Northbound APIs are the same. It's
Yeah,
fine to
I
use tags.
understand that the tag to the customer, to the tenant, it's a nice feature, but does it provide any benefit in the data plane? I don't see it. Maybe somebody else does, but if
I guess the reference would be, do we do that? Do we use tags going into VFP today, Prince?
Yes.
That's what I thought. So obviously we think there's a
do you
reason,
have a behavioral model today for that?
because it's proprietary. So no.
So
But the point is, we should find out if we have tags going into VFP today, which is our current implementation on all of our servers. We should figure out why do they have tags and what did it do for them.
And
I don't think it was arbitrary. I mean, if they're using them, they must have had a reason.
what I would say also is we talk about the API generation and all that, but the point is the implementation right now doesn't match, and maybe it was not defined properly. I don't know. But what we have here, the logic, the rule match logic here, it's really important. That's what tags are about. So if we agree on that one here, the definition that we have currently doesn't match that. That's just a fact. So
And agreed that should be fixed if
yes,
it's a bug, right?
The feature is about this rule match logic right there if we are to support tags. In my opinion, it's not the case.
right. So I mean,
one way forward would be to change the P4 code to just do ternary on source and dest address, and say that in the reference model code, I think as Chris suggested earlier, do the cross-producting, eliminate tags. And the northbound API has tags, the P4 code doesn't, and
I wouldn't call it.
No,
I wouldn't call it cross-producting. I would call it prefix expansion or something. It's actually the opposite of cross-producting. It's trying to preserve the number of rules.
Well, yeah. If it expands source tags and dest tags, and you only have ternary in the hardware in the P4 code, and you have a list of 100 source IP prefixes and 100 dest IP prefixes in a single rule, that has to be expanded into 10,000 ternary entries, right?
Oh, I mean, if you want to go all the way to ternary, like TCAM for the entire ACL, sure, you could do that.
I mean, that would clearly match that would be a behavior model that clearly matches this definition. Very simple to implement. It just takes up huge memory if you have large configs.
Yes.
But it's only a reference model.
I think that's the point, right? Like we should not end up taking the entire memory for just the ACLs, right? With
but it's a reference. It's a reference model.
The memory of the behavioral model, not
even when in the current model, when we expand this to tags with 10,000 prefixes and we push each rule with those list of prefixes, right? I mean, it can blow up the memory.
It's a vendor problem, though, right?
In the behavioral model. Do you care about the behavior model's scaling?
No, we don't. not about the behavioral model. Like the point is about usage of tags, right? I mean, I'm not sure like if AMD or Marianne or someone can chime in on their expectation of tags, and if it can save memory. But that's the whole intention of tags.
But the implementation specific details of whether or not you take advantage is vendor specific. It doesn't matter. And Andy, you were talking about ternary stuff. Well, that again should not apply, be pushed back to the API anyway, right? Again, it's an underlying how do you solve the logic in P4 for the behavioral model given a different side API, right?
So northbound API we're talking about is to the control plane caller. Southbound is to the data plane. I'd say northbound needs tags, keep them. Southbound optionally have tags, but some targets, like you say, you can expand out tags if they don't support them, and the reference model would be one that doesn't support tags.
I mean, to be honest, for me, the SI API, if it were based on the definition that, you know, a tag has a list of prefix, I would be perfectly fine to have that at the SI API. Yep. And then a vendor could decide to do whatever the heck he wants to do. Not the case now. What we have now just doesn't make sense to me. But I don't see a so you can either say I don't have the tags period at the SI API, or you could have it, but the right way, I would say, the more logical way, I suppose.
Right. I agree with Vincent. I mean, this API on this screen is fine. Like we don't have a problem with this API. It's just that this API should be a single rule in the data plane, not expanded to like a cross product of rules. I mean, the behavioral model can do that if it needs to do that, but it shouldn't be done on the vendor implementation. The vendor should be able to accept this API exactly as it is with any arbitrary list of source tags and dest tags and source prefix and dest prefixes. And we shouldn't be limited to 32 tags. I think we should implement the feature as it's defined.
No, I think again that 32-bit is not the intention, right? I like I said, it's depending on the capability. So of course, some P4 generated APIs may have to be hand modified. So this 32-bit is not the one.
But think about the API. Think about the API. Let's say I say that I could support 4K tags.
Mm-hmm.
Every time you add a prefix to the data plane, you're going to provide a 4K map of bitmap with that. It's like it seems like a very inefficient way of implementing of defining the API. The original definition of the API, where a tag is a list of prefixes, seems much more scalable than doing it the opposite way, where each prefix now is associated with a 4K bitmap.
And like we need an API to define the tags too, with this that accompanies this slide here, right?
Yeah, that's right. I think it was on the previous slide. I mean, this is what was proposed for the feature. And this is fine. Like, I have no problem with this definition or this definition. What I have a problem with is that taking a behavioral model that doesn't implement these and now pushing constraints, you know, like, for example, we're going to now expand into many, many more rules than these APIs themselves would have needed.
Mm-hmm.
So and I honestly believe if we had a C model instead of a P4 model, I'm not suggesting we change. I mean, if everybody wanted to change, I wouldn't oppose it. But if we had a C model instead of a P4 model, nobody would be complaining about this topic today.
Is it possible to have both and just use C for this particular feature and integrate them together?
That's sort of similar to the unfulfilled task of just enhancing the behavioral model. We already have a C++ framework.
Yeah.
right? All I do is add a feature.
Maybe we should pick this up next week. It's 10:08. Or do you guys want to keep going?
I think I need to drop. Yeah.
Okay.
Okay.
I think next week we should concentrate on how do we come to resolution on this, because
Yep.
we've talked about it for 5 weeks.
Mhm.
Maybe we concentrate on like how do we come to a resolution? What is the steps that we're going to need to take? Because otherwise we'll talk about it for 5 more weeks.
Okay. So, John, thank you for putting together the slides.
Yeah,